Military technology is the application of technology for use in warfare. It comprises the kinds of technology that are distinctly military in nature and not civilian in application, usually because they lack useful or legal civilian applications, or are dangerous to use without appropriate military training. Military technology is often researched and developed by scientists and engineers specifically for use in battle by the armed forces. Many new technologies came as a result of the military funding of science. Weapons engineering is the design, development, testing and lifecycle management of military weapons and systems. It draws on the knowledge of several traditional engineering disciplines, including mechanical engineering, electrical engineering, mechatronics, electro-optics, aerospace engineering, materials engineering, and chemical engineering. The line is porous. Military inventions have been brought into civilian use throughout history, with sometimes minor modification if any, and civilian innovations have similarly been put to military use. History. This section is divided into the broad cultural developments that affected military technology. Ancient technology. The first use of stone tools may have begun during the Paleolithic period, about 2 million years ago, and evolved through the Pleistocene period, about 12,000 years ago. Stone tools are evidence of the earliest technological development to shape and sharpen minerals such as chert, flint, and obsidian into bludgeoning devices and other trauma weapons. The earliest evidence of warfare between tribes of humans date back to the Neolithic period at Cataluyuk in Anatolia and Jericho, about 7000 to 6000 BCE, where primitive fortifications and stone weapons have been found. Humans entered the Bronze Age as they learned to smelt copper into an alloy with tin to make more effective and specialized weapons like swords, spears and shields. In Asia, where copper-tin ores are rare, this development was delayed until trading in bronze began in the 3rd millennium BCE. In the Middle East and southern European regions, the Bronze Age follows the Neolithic period, but in other parts of the world, the Copper Age is a transition from Neolithic to the Bronze Age. Although the Iron Age generally follows the Bronze Age, in some areas the Iron Age intrudes directly on the Neolithic from outside the region, with the exception of sub-Saharan Africa where it was developed independently. Craftsmen developed metallurgical techniques to improve the tensile strength of bronze, and then iron alloys, allowing longer and stronger blades that resisted breakage. Iron Age weapons accelerated battlefield effectiveness with even more specialized weapons and blades that could be easily sharpened and held their edge longer. The first large-scale use of iron-type weapons began in Asia Minor around the 14th century BCE and in Central Europe around the 11th century BCE, followed by the Middle East and India and China. The Assyrians are credited with the introduction of horse cavalry in warfare and the extensive use of iron weapons by 1100 BCE. Assyrians were also the first to use iron-tipped arrows. Post-classical technology. The Wu Jingzong Yao, written by Zheng Gongliang, Dingdu, and others at the order of Emperor Renzong around 1043 during the Song dynasty illustrates the era's focus on advancing intellectual issues and military technology due to the significance of warfare between the Song and the Liao, Jin, and Yuan to their north. The book covers topics of military strategy, training, and the production and employment of advanced weaponry. Advances in military technology aided the Song dynasty in its defense against hostile neighbors to the north. The flamethrower found its origins in Byzantine-era Greece, employing Greek fire in a device with a siphon hose by the 7th century. The earliest reference to Greek fire in China was made in 917, written by Wu Renchen in his Spring and Autumn Annals of the Ten Kingdoms. In 919, the siphon projector pump was used to spread the fierce fire oil that could not be doused with water, as recorded by Lin Yu in his Wu Yu Beishi. Hence the first credible Chinese reference to the flamethrower employing the chemical solution of Greek fire. Ling Yu mentioned also that the fierce fire oil derived ultimately from one of China's maritime contacts in the southern seas, Arabia, Dashiguo. In the Battle of Langshanjiang in 919, the naval fleet of the Wenmu king from Wu defeated a Huainan army from the Wu state. Wenmu's success was facilitated by the use of fire oil to burn the fleet, signifying the first Chinese use of gunpowder in a battle. The Chinese applied the use of double-piston bellows to pump petrol out of a single cylinder, lit at the end by a slow-burning gunpowder match to fire a continuous stream of flame. This device was featured in description and illustration of the Wu Jingzhongyao military manuscript of 1044. In the suppression of the southern Tang state by 976, early Song naval forces confronted them on the Yangtze River in 975. Southern Tang forces attempted to use flamethrowers against the Song navy, but were accidentally consumed by their own fire when violent winds swept in the direction. Although the destructive effects of gunpowder were described in the earlier Tang dynasty by a Taoist alchemist, the earliest known existent written formulas for gunpowder come from the Wu Jingzhongyao text of 1044, which described explosive bombs hurled from catapults. The earliest developments of the gun barrel and the projectile fire cannon were found in late Song China. The first art depiction of the Chinese fire lance was from a Buddhist mural painting of Dunhuang, dated circa 950. These fire lances were widespread in use by the early 12th century, featuring hollowed bamboo poles as tubes to fire sand particles, lead pellets, bits of sharp metal and pottery shards, and finally large gunpowder-propelled arrows and rocket weaponry. Eventually, perishable bamboo was replaced with hollow tubes of cast iron, and so too did the terminology of this new weapon change. From fire spear, huo qiang, to fire tube, huo tong. This ancestor to the gun was complemented by the ancestor to the cannon, what the Chinese referred to since the 13th century as the multiple bullets magazine eruptor, by Zulian Zhu Pao, a tube of bronze or cast iron that was filled with about 100 lead balls. The earliest known depiction of a gun is a sculpture from a cave in Sichuan, dating to 1128, that portrays a figure carrying a vase-shaped bombard, firing flames and a cannonball. However, the oldest existent archaeological discovery of a metal barrel handgun is from the Chinese Heilongjiang excavation, dated to 1288. The Chinese also discovered the explosive potential of packing hollowed cannonball shells with gunpowder, written later by Zhao Yu in his Huo Longjing. This manuscript recorded an earlier Song-era cast-iron cannon known as the Flying Cloud Thunderclap Eruptor. The manuscript stated that, as noted before, the change in terminology for these new weapons during the Song period were gradual. The early Song cannons were at first termed the same way as the Chinese trebuchet catapult. A later Ming dynasty scholar known as Mao Yuanyi would explain this use of terminology and true origins of the cannon in his text of the Wubeig, written in 1628. The 14th century Huo Longjing was also one of the first Chinese texts to carefully describe the use of explosive landmines, which had been used by the late Song Chinese against the Mongols in 1277, and employed by the Yuan dynasty afterwards. The innovation of the detonated landmine was accredited to one Luo Qiangxia in the campaign of defense against the Mongol invasion by Kublai Khan. Later Chinese texts revealed that the Chinese landmine employed either a ripcord or a motion booby trap of a pin releasing falling weights that rotated a steel flint wheel, which in turn created sparks that ignited the train of fuses for the landmines. Furthermore, the Song employed the earliest known gunpowder-propelled rockets in warfare during the late 13th century, its earliest form being the archaic fire arrow. When the northern Song capital of Kaifeng fell to the Jurchens in 1126, It was written by Qie Shaozheng that 20,000 fire arrows were handed over to the Jurchens in their conquest. An even earlier Chinese text of the Wu Jingzong Yao, written in 1044 by the Song scholars Zheng Konglang and Yang Vide, described the use of three-spring or triple-bow arqueballista that fired arrow bolts holding gunpowder packets near the head of the arrow. Going back yet even farther, the Wu Li Xiaoshi of Fang Yizhi stated that fire arrows were presented to Emperor Taizu of Song in 960. Modern technology. Space. During the Cold War, the world's two great superpowers, the Soviet Union and the United States of America, spent large proportions of their GDP on developing military technologies. The drive to place objects in orbit stimulated space research and started the space race. In 1957, the USSR launched the first artificial satellite, Sputnik 1. By the end of the 1960s, both countries regularly deployed satellites. Spy satellites were used by militaries to take accurate pictures of their rivals' military installations. As time passed, the resolution and accuracy of orbital reconnaissance alarmed both sides of the Iron Curtain. Both the United States and the Soviet Union began to develop anti-satellite weapons to blind or destroy each other's satellites. Laser weapons, kamikaze-style satellites, as well as orbital nuclear explosion were researched with varying levels of success. Spy satellites were, and continue to be, used to monitor the dismantling of military assets in accordance with arms control treaties signed between the two superpowers. To use spy satellites in such a manner is often referred to in treaties as national technical means of verification. The superpowers developed ballistic missiles to enable them to use nuclear weaponry across great distances. As rocket science developed, the range of missiles increased and intercontinental ballistic missiles were created, which could strike virtually any target on Earth in a time frame measured in minutes rather than hours or days. In order to cover large distances, ballistic missiles are usually launched into suborbital spaceflight. As soon as intercontinental missiles were developed, military planners began programs and strategies to counter their effectiveness. Mobilization. A significant portion of military technology is about transportation, allowing troops and weaponry to be moved from their origins to the front. Land transport has historically been mainly by foot. Land vehicles have usually been used as well, from chariots to tanks. When conducting a battle over a body of water, ships are used. There are historically two main categories of ships, those for transporting troops, and those for attacking other ships. Soon after the invention of aeroplanes, military aviation became a significant component of warfare, though usually as a supplementary role. The two main types of military aircraft are bombers, which attack land or sea-based targets, and fighters, which attack other aircraft. Military vehicles are land combat or transportation vehicles, excluding rail-based, which are designed for or in significant use by military forces. List of military vehicles. List of armored fighting vehicles. List of tanks. Military aircraft includes any use of aircraft by a country's military, including such areas as transport, training, disaster relief, border patrol, search and rescue, surveillance, surveying, peacekeeping, and aerial warfare. List of aircraft. List of aircraft weapons. Warships are watercraft for combat and transportation in and on seas and oceans. Submarines. Complex masting and sail systems found on warships during the Age of Sail. List of historical ship and boat types. List of aircraft carriers. List of submarine classes. Defense fortifications are military constructions and buildings designed for defense in warfare. They range in size and age from the Great Wall of China to a Sangar. List of fortifications. List of forts. Sensors and communication. Sensors and communication systems are used to detect enemies, coordinate movements of armed forces and guide weaponry. Early systems included flag signaling, telegraph and heliographs. radar, missile guidance, satellite guidance and guidance weapons, Norden bombsight, proximity fuse, future technology. The Defense Advanced Research Projects Agency is an agency of the United States Department of Defense responsible for the development of new technologies for use by the military. DARPA leads the development of military technology in the United States and today has dozens of ongoing projects, everything from humanoid robots to bullets that are able to change path before reaching their target. China has a similar agency, Emerging Territory Cyberspace. In 2011, the U.S. Defense Department declared cyberspace a new domain of warfare. Since then, DARPA has begun a research project known as Project X, with the goal of creating new technologies that will enable the government to better understand and map the cyber territory, ultimately giving the Department of Defense the ability to plan and manage large-scale cyber missions across dynamic network environments.